Guys, welcome back. So what we're looking at today are lessons 10 and 11. So lesson 10 is meet slope. So let's go ahead and jump right in. So what we're looking at here, similar triangles on the same line. The figure shows 3 right triangles, each with its longest side on the same line. So we are going to complete the table based on these triangles here. So looking at this, if we look at the vertical and horizontal side, then we're going to look at dividing the two. So in A, B, C, the horizontal sides, remember horizontal would be parallel to the x-axis. It's flat. Vertical is the up and down. So horizontal is left to right, vertical is up and down. So the horizontal side is 4, the vertical side is 3. So horizontal side is 4, vertical side is 3. So if we do vertical divided by horizontal, we have 3 divided by 4, which is 0.75. All right, so let's look at CDE. CDE. We want its vertical side, which is 6, as well as its horizontal side, which is 1, 2, 3, 4, 5, 6, 7, 8. Which is 8. So we've got 6 and 8. So 6 was our vertical side, 8 was our horizontal side. 6 divided by 8 is also 0.75. Now we look at FGH. So here we have a side of 2 for our horizontal, and our vertical is 1.5. So 1.5 for our vertical, and 2 for our horizontal. So we take our 1.5, we divide it by 2, we end up with 0.75 as well. So all of these triangles have the same quotient for their for their diagonal sides. So when we take the 2, not our diagonal side, for our vertical divided by horizontal. So dividing these, we get the same relationship, which shows us that these are similar triangles, despite the fact that obviously they're all different sizes. And it also gives us our slope. So the slope is taking the horizontal or the vertical length and dividing it by the horizontal length. So the slope of that line is 3/4 or 0.75. So our horizontal and vertical lengths, we use those to find slope. So for number 2, or for the next thing, we're looking at drawing 2 lines with a slope of 3. What do we notice about the 2 lines? Then we're going to draw 2 lines with a slope of 1/2. So here we have our graph. Now, you can use the slope triangles by all means to help you with this. So we want a slope of 3, which means we need to have a vertical height of 1, 2, 3, and a horizontal height of 1. So the line from here to here is a slope of 3. So we do it again. So go up 1, 2, 3 over 1. Go up 1, 2, 3 over 1. This right here, and I know my line is not going to look very straight in the slightest. This is our line. Obviously, mine is very wavy, but you get the idea. Mark those points, and then you guys can draw a nice straight line. Now, if we do it again, here's our starting point. I'll make these a little bigger so you can see them better. So here is our starting point, just like this was our starting point. 1, 2, 3, 4, 1. Okay. So we go up 1, 2, 3. We have a vertical height of 3. We have a horizontal height of 1 to get a slope of 3. We go up 1, 2, 3 again. We go over 1. We go up 1, 2, 3. We go over 1. Now, between each of these points, we can make slope triangles to show that this does have a slope of 3. And then we can draw the line that goes between these. I'm going to shrink that down so you can see the points better. So obviously my line is very, very crooked and wavy, but you get the idea. It's going to go between those points there. This has a slope of 3. Now, if we draw lines with a slope of 1/2, So I'm going to change the color. So that means for 1/2, our vertical is 1 and our horizontal is 2. So starting here, we go up 1 because that's our vertical and over 2. That's our horizontal. Up 1 and over 2. Up 1 and over 2. Up 1 and over 2. Then we can draw the line that goes between these. That will have a slope of 1/2. So connect all these points as best you can. Obviously mine's a little off. Now we do it again for another one. So let's start here. Here's 1. We go up 1 over 2. Up 1 over 2. Up 1 over 2. Now we draw the line in between them. Obviously mine is very, very, very wavy, but you get the idea. So these are our 2 sets of lines. So the purple ones have a slope of 1/2. The blue ones have a slope of 3. So key thing with this is understanding how we can draw them. So understanding what slope represents. Slope represents the steepness of our lines. So it's showing us the change in the vertical distance over the horizontal distance. So it's all about looking at those values. So slope equals vertical distance over horizontal distance. It's crucial to know that and understand that. You'll be using slope over and over and over again throughout your math career. All right, so here are several different lines. We have all these lines some with slope triangles, some without, and we want to match each line shown with a slope from the list. One of the slopes does not have a line to match. Draw a line for this in the empty grid. So I'm going to make this much bigger so we can see it. Okay, so let's look at the ones that have the slope triangles first. So here we have 2. Here we have 1, 2, 3. Remember, slope is always vertical over horizontal. So what's our slope? 3 over 2. So that one's gone now. The next one, we have 1, 2, 3, 4, 5, 6. We have 6 for our horizontal and 1, 2 for our vertical. Now, do we have a 2 over 6 down here? No, but 2 over 6 reduces down to what if we divide them both by 2? Reduces down to 1/3. So this is a 1/3 slope. All right, the next one we have 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So 5 over 5 is the same thing as 1. This has a slope of 1. All right, now, each of these already had the slope triangle drawn out. What we're going to do on the other ones is we're going to draw that slope triangle. So key thing when we do our slope triangles, we don't want to choose this point right here where I have my mouse. It's not on an exact grid intersection. But notice right here, this line is meeting exactly with this vertical line and this horizontal line. So start right here. And then we're going to go over. And then if we look up, look, it's right at another intersection. So that tells us this is our triangle. So we have 1 on the bottom for the horizontal, 2 for the vertical. So our slope is 2 over 1 or 2. So be very careful with those slopes. The larger the whole number, the steeper the slope. If it's a fraction, it's going to be a flatter slope. So here, if we look at this one, we've got an exact point here. Go over all the way to here and then up. So we've got 1, 2, 3, 4. And we have 1. So this is 1/4, which is the same thing as 0.25. So the one we don't have is the 1/2. So if we start right here, make our point, we go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now, draw the line between those points, and we will have our slope of 1/2 for our line. So 1/2. So this is what slope is. So like I said, slope is the vertical distance over the horizontal distance. It's crucial that you know how to find a slope. Okay? All right. Lesson 11. So we're looking at on lesson 11 is writing equations for lines. So with that, we need to know what slope is. So that's why we're doing these together. So line J is shown in the coordinate plane. What are the coordinates of B and D? So if we look, we went over 4 and up 3. So B is 4, 3. And D, we went all the way over here to 8 and then up to 6. So D is 8, 6. We always label them in XY form. Okay? So is the point 20, 15 on line J? Explain how you know. So what we need to look at is figure out what the slope is for this line. So what's our horizontal? Well, we've got 4 and 3, so we have a 3/4 slope. If we take our y value, because that's our vertical, and divide it by our x value, which is our horizontal, what do we get? 3/4. So yes, it is. It has the same slope. Do the same thing with 175. 75 goes on top, 100 goes on the bottom. That's the same thing as 3/4. So yes, it is. The next one, 68 over 90. Is this going to simplify down to 3/4? Nope, it does not equal 3/4, so no, different slope. Suppose you know the x and y coordinates of a point. Write a rule that would allow you to test whether the point is on line J. So the quotient of the y coordinate and the x coordinate has to be 3/4. Describes the relationship on a line for every point but 0, 0, because obviously 0, 0 isn't going to work. So y over x. All right, so writing relationships from slope triangles. Here are 2 diagrams. So you've got this one here and this one down here. Diagrams, so all vertical and horizontal segments have expressions for their lengths. So if we look at these, triangle ABC has the values of 3 and 4, but triangle DEF does not. So if we look at the values given, so even though these aren't proportional relationships, they aren't going through the origin, we can still use what we know to be able to take and solve these. So on our line here, the segment DF, if we look, it's 1 away from the origin. So our y value that we have up here at E isn't the exact vertical value that we're going to have. It's a little different. It's going to be 1 less than what E is. So this side will be labeled y minus 1. This side, because it's at on the y-axis, we can just label this x because it's right on the y-axis, so we can exactly measure our x value. Now for this one, notice our triangle's way over here. It's not right at the x value, so looking at point F for our distance or length of our horizontal, we can't do that. But it's 2 over, so we do x minus 2. And then for